Hey guys, this will be example 5 for section 3.2. So remember, we just did a discrete one that had individual points because the tickets you can only buy one at a time. So now let's look here. A cereal bar contains 130 calories. The number of calories consumed is a function of the number of bars eaten. Does the situation represent a linear function? Explain. So when we're looking for a linear function, we're thinking of a constant rate of change. So as the bars increase by 1, C increases by 130. The rate of change is constant. What that means is it's not like the bars change the amount of calories you get. 1 bar, 130 calories. 2 bars, 260 calories, or another 130. Okay? It is a linear function because we have a constant rate of change. The number of calories changes every time by the same amount, by 1 bar. Now, you can eat part of a cereal bar, right? Sorry, I didn't mean to click that ahead of time. So when we're trying to find if it's discrete or continuous, you don't have to eat 1 bar at a time. You can take bites, and you can take different size bites. So from your first nibble on, the amount that you take could be any decimal point of a bar, okay? So your domain is b greater than or equal to 0. Think about what that means. B stands for the number of bars eaten. You can't eat negative bars. You can eat 0 bars, you just leave it down. We eat no cereal bars. After that, you can take as small of a bite as you can imagine. Well, I don't know why that went back. Sorry, let me click ahead. So you can take the smallest bite you can imagine all the way up to eating, theoretically, as many bars as you want. You could eat an infinite number of bars. In this scenario, in the real world, you would have a cap somewhere, probably maybe 50 bars is the most a human can consume. But for this is purely theoretical. So we're saying you could eat infinitely many bars. Okay. So now we have to think, if our domain, why does it keep glitching? If the domain can go on forever, then what about the range? So here we have these input values. 1 bar is 130, 2 is 260, 3 is 390, 4 is 520. Plot the ordered pairs. But you notice how we connect the line through them. This is the power of drawing lines. Since it is a constant rate of change, this graph gives us everything we can know, and it plots every other theoretical point. We know at 0 bars, we have 0 calories. 1 bar, 130, 2, 260. But what if I had 1.5? Wouldn't that be around here? 1.5 would be right here on the graph. 1.5 would be right around 200 calories, okay? And you actually could plug it in and think of 1.5 times 130 would be what? That would be your exact answer. But you see how this gives us a rough estimate? So graphs are a great, quick, and dirty way to get an answer. But it is not always a perfect answer because I can't see it perfectly on there. But what if I ate 6 bars? Well, look, 6 looks to be right around 800. It'd be about 800 calories. Do I know exactly? No. And I doubt it's exactly 800. If I look at 5, if I had 5 bars, that would be about 650. What if I said, how many bars would I have to eat in order to get 450 calories? Well, I'd go here, 450 calories, and then go down to where it matches. That's about 3.5 bars. Okay. So this is the strength of continuous graphs. When you need a continuous graph, lines, you can always just get a couple points and use a ruler. I have a couple points. I take a straight edge or a ruler. I connect the dots. Now I know information about every amount of bars that could be eaten. I don't know completely accurate information, but I have a really, really good idea. So ask me if you have more questions on this in class, but that's example 5. Example 6, I'm going to let you guys try on your own. I'll be doing that in class. I will not be doing that on YouTube. Thank you guys very much. Good luck on your homework and on your monitoring progress.